Welcome everyone. Good afternoon, good morning for those of you who are watching from further shores, and welcome to this presentation on Dockerizing your OpenEdge application and developing it in a browser. Mike Liewehr and I are going to take you through the journey that we've taken Build.One on in getting started with Dockerizing the application and also getting it into what we think is a really exciting development environment and opening up for a lot of new possibilities. Very quick introduction. My name is Hansen. I've been working with Progress OpenEdge since 1995. So as we've talked about before, I'm one of the younger people in the crowd when it comes to Progress. Working with consulting most of the time, but a lot with Docker and containers, and ever since Docker really came out and done a lot of different projects on that. Application lifecycle management, DevOps, with OpenEdge, automating things in the OpenEdge world has really been one of my key focus areas and what I've worked with, both working with Progress many years ago, working with my current company, appSolutions, and also in the Notable team that I've worked with as well. Working with also security products like Securable from Notable is also something I've spent quite a bit of time on over the last couple of years. Okay, and Mike?
Yeah, also very warm welcome from me. I'm Mike Liewehr from Build.One. Most of the Progress community knows us as Axioma. So we have recently done a rebranding. So that's the same company, a new name. Name is now Build.One, but it's the same product and the same company. And the focus of Build.One is we've developed a low-code, no-code platform. So the idea of Build.One is that we combine no-code, low-code, and professional coding into one platform to develop complex business applications. And the idea is that you are much faster in developing those business applications, but still you can develop very complex applications. Let's go over that very briefly here. So the idea is that with coding, you are not fast enough and it takes too long, it's too expensive, and time to market is an issue. And with traditional low-code, no-code approaches, you just cannot build real complex business applications. And yeah, with Build.One, we aim at covering those and bring those two worlds together. Not going into this into detail, I think you're more interested in the whole Docker stuff. So yeah, very quickly, the idea of the Build.One platform is that we store everything in repositories. We call that a blueprint, and we don't generate code. And then at runtime in the browser, we have a rendering engine that we developed that runs in the browser, gets that blueprint, so to speak, the description of your application and of your screens, renders it in the browser, and yeah, that way we achieve that we'll never have legacy again, because we can always reinterpret the blueprint depending on the platform and the changes in web UI technologies and standards. So yeah, that's the core idea here, is that we combine no-code, low-code, and professional code in one platform. And yeah, we address direct customers as well as ISVs, and we have customers who use Build.One to really build their core application, an ERP, a CRM, and others are using it to enhance their core applications, building add-ons and additional functionality for their ERP or other core applications. Yeah, but this talk is about our Docker journey together with Thomas. So yeah, I hand over to you.
All right. So we're going to talk about the Build.One Docker journey, which is a term we've been using on multiple projects. We work with customers. We start them on the journey of containerizing or Dockerizing their applications. And for the Build.One environment, one of the first things we when we started, we were obviously looking at the existing environments that they have in terms of development, Windows environment, OpenEdge code development for some of the back-end code that they work on, using Developer Studio, but actually most things were already on Linux, so databases, continuous integration delivery tools, PaaS-OE, application, and the web UI for the application. All of that stuff different from the presentation I was on yesterday together with Bronco, where the big challenge was getting everything off Windows first and actually make it more compatible in a container environment. This process was easier in this setup here. In terms of deployment, most things Linux-based, and because the Build.One application is web-based, most of the things that make up the application, databases, PaaS-OE, again, all of those things in deployment are already running on Linux. So that made the task of getting started with containers a lot easier. But really what we're trying to achieve is a fully containerized development, build and testing, and also deployment environment. So that's really the ultimate target of this journey that we've started on. I'm not going to go into a lot of detail about why to containerize. For those of you who were on the talk that we had yesterday, we went into that in a little more detail. So I'll sort of skip very quickly through this, but benefits are things like building and testing your environments and the components with that, deployment, scalability, flexibility, use of resources on the different platforms and servers and so on that you're working on, moving away from dependencies on Windows and other heavy, sort of more operating system focused dependencies. So one of the things that we always start with is what have we got available when we're talking about OpenEdge applications in terms of images that we can work with? What building blocks do we have available to start with? What's available out of the box at the moment? Well, we've got some official OpenEdge images available. We've got a PaaS-OE runtime, and we've also got database images that we can use as building blocks for creating our own images and to create containers that we can work with. For databases, we'd use that for creating pre-built snapshots of the different application databases that are both used for development in this case, but also for testing and proof of concepts and demos and so on. But it's really been taking snapshots and storing those so we can instantaneously spin up databases with or without data, depending on what the needs are. But one of the things that's very common in this project, as well as in any other OpenEdge projects that I've been involved in, is the need to create some custom OpenEdge images, because we need a generic image that we can do builds and compiles and run tools and so on that we don't get from Progress as part of the standard images that you can download from their software download. So we create some images that are basically Linux installations inside Docker images. It's a full OpenEdge installation. It's a pretty bloated image, so each image is about 2 gigabytes in size, so it's got everything that you need in there. We haven't really done a lot to trim it down, but we have all the tools and all the functionality that we need in there. We can use it to run databases and PaaS-OE, we can run tools, we can do compiles and so on. That's one of the key things that we need here. So in moving on with the Build.One Docker journey, the existing development environment, we had the development servers, Windows servers using RDP. We had Linux backend for databases and other components. Code is stored, any code and configurations and setups and so on in Bitbucket, Git repositories, and they're using Jira for issue tracking. All parts, things that are also integrated into the Build.One development environment that Mike will show a little later. And one of the checks that we always have to do, and depending on what we're starting with, the result of that will obviously be different, is how ready is this system for containers? Well, in this particular case, the application components, they both compile and run on Linux, so check for that. There's no code refactoring needed. There may be some restructuring in how we put together different components or the different images, but moving the OpenEdge parts into containers is fairly straightforward. The same with databases, because the databases are already ported to and running on Linux. The web-based front end that makes up part of the Build.One platform is already compatible, and in many cases the web-based front ends are actually the easy things to move into containers. There's no Windows dependencies. It's deployed together with Apache as a front-end component, and so that was pretty straightforward. And the same thing with the CI/CD tools that are running. They already had Jenkins pipelines running and had things available there that we can quite easily port to containers when we need to do that. One of the tools that is an important component in all of this that we've been looking at is Visual Studio Code that more and more people are using. Visual Studio Code was already in use here with front-end development, with tools development, and one of the things that Mike and I had spoken often about was the ability to use Visual Studio Code for OpenEdge development. And there are some plugins available to do that, but we'll get a little more onto that in a bit. One of the things that's interesting with Visual Studio Code as well, especially when we're getting into talking about Dockerizing and working with containers, is that Visual Studio Code works very nicely with Docker. If you've got everything, all of your stuff on a Linux host, you can use the built-in SSH client to connect up to your host, and then there are some very good Docker extensions that allow you to work together with Docker containers and see images and volumes and all those things that you're working with there. And in that way, very easily work with the built-in terminal also to access Docker and Docker Compose running on the host. If you're running Windows 10 or Windows 11, or you're on a Mac, then you also have the Docker desktop, which allows you to work interactively with things on here. Now, if you want to do some OpenEdge development with Visual Studio Code, there are some extensions available. They work both for Windows and for Linux. And they give you some basic features: syntax highlighting, syntax checking, running code, a little some debugger support, a little autocomplete after having read the schema. But it's not really there yet. And I think most of you know that there is some stuff happening in that space, and Gilles is going to be demonstrating some stuff that he's doing on a Visual Studio language server for OpenEdge I think in the next session actually. So, one of the things that Mike and his team decided as we started looking at all this was actually to start using Visual Studio Code with the SSH connection to Linux, and then start using what was available in terms of the OpenEdge extensions here. And that sort of is one of the precursors for some of the stuff that we are working on at the moment. So when we're setting up an environment like this, one of the things that, important things to look at is what are the different components of the application, how do we divide it into images. We're not going to go into a lot of detail with that here, but we end up with a number of some custom OpenEdge images that we can use for development and build and compiles and so on. We need to segment the application into different images, different components of the application, so that we can build demo runtime stacks and development stacks with the different container-based configurations of the application, and really show how easy it is to quickly spin up an instance of the application. So we put things like databases, OpenEdge PASOE, Tool Hub, which is a tool that's part of the Build.One environment for running and compiling and building and packaging and doing a lot of stuff on the back end of the application environment. Apache, which is the part of the front end component. There's a node component, and then there's the actual web UI also. So we've got lots of different components that we put together here. And when we do that, we get into a development environment that has at the bottom stack down here has a series of different containers. When we spin up a typical environment, it would have PASRE on the back end, the tool hub, the web UI, Node.js, all of those being served and made available through an Apache container that's part of that. We've got databases that are all here, all of these running within a container-based stack. And then we set up something like traffic as a load balancer to serve these environments here, all of this running on a Linux host that you can then you can access this entire application stack from a web browser. And once you've got something like this in place, you can very easily go from one to many stacks because you've got everything in containers. You've got your if we're using Docker Compose, for example, we've then we can very easily start up multiple instances on the same machine, make better use of resources, quickly spin up and test stuff and tear down and so on, which is part of the benefits of going into a containerized environment. One of the things that we've talked a lot about was, well, what in terms of development, are there better options available than being dependent on having to log on to a host somewhere? And I know that Mike's had a vision for a long time about being able to have everything completely web-based, just like the Build.One environment is. And we've talked about various ways of getting a completely web-based, self-contained, container-based development environment set up. And one of the first things that came up with that was actually something called Eclipse Chain, which was the next generation of Eclipse. That had a lot of promise, and Progress actually spent quite a bit of effort building the Hub for DevOps product, but I'm actually not really sure what happened with that. The Eclipse Chain stuff was heavy and not really used very much, and we actually ended up, although we spent a lot of effort trying to set it up, we actually ended up parking that because it didn't really seem to be going anywhere.
Was also we were not able to get it to work in our own environment, not in a self-hosted way. So. Yeah,
and so you ended up being very dependent on running it on a hosted system provided by Red Hat, who'd taken over Eclipse and were sort of more focused on it running on their environments than anywhere else.
And I look at it every few weeks, and it seems to not move at all. So.
Another important one is Microsoft Code Spaces. And Microsoft actually had something very much using the Visual Studio Code server, but running, also making it available in a web browser. Microsoft actually had Microsoft Code Spaces and GitHub Code Spaces happening at the same time. They actually parked one of their own one and took over the development on GitHub Code Spaces. Looked very promising, but it's very dependent on running virtual machines on the back end on the Microsoft infrastructure.
And the one they parked, as you mentioned it, was of course the one we tried next, so which looked very promising actually. It worked fine.
Yeah.
We were able to install it in our own environment, and then all of a sudden, one morning I read that it's cancelled, and now everybody should go to GitHub Code Spaces or so.
Yep. So that brought up another interesting one, which is Gitpod, and I'll let you talk a bit about that.
So yeah, we did, after looking or investing a lot of time and efforts into Eclipse Chain and the DevOps hubs, or however Progress called that stuff, and then the Microsoft Code Spaces, and we did not make then the move to GitHub Code Spaces, but we then stumbled upon Gitpod, which is the same idea. It's really about developing in the browser and having development workspaces as Docker containers. They call it ephemeral workspaces, so meaning you start up a workspace from scratch. If you want to develop something, you do your task, you commit, you push, you shut down the workspace, and it's gone. So really you start up and delete workspaces all the time for each task. We looked into that one, and that looked very promising. It's based on also Visual Studio Code, running in a Docker container, and it's also based on Docker in Docker. So we show this live, and I think then when I show it live, Thomas can explain that way better than I can. And it really works well, and it has a lot of very interesting features. They also seem to get a lot of traction. They're based in Germany, actually, and talked to them, and they have, within a year, they have more than 400,000 developers using it. So it's really quite successful. And we've integrated the Gitpod with the Build.One platform to finally, hopefully, get to that or fulfill that vision that you can develop in the browser without having to install anything. So the idea when we started all this, I think, when did we start with Eclipse Chain? 2 years ago or longer?
Something like that, yeah.
So the vision that we had was always that the Build.One platform is really for developing complex business applications with a low-code, no-code approach and professional code. So when we developed the platform, we always said, you should be able to develop the next SAP with this, or the next QAD or whatever. And now with the Docker and containerized development workspaces, the vision is really that if you have a team of 50 developers spread across the world and you really want to develop a complex business application, the idea is that you just log into the Build.One environment, you register, and then you can start developing without having to install anything locally or anything on a server. So the only thing you need is a browser. And it even works on my iPad. So we implement all the tooling, we implement CI/CD, and all that kind of stuff. We have graphical editors as part of the platform. And of course, if you aim at really developing a ERP, you also need to code. The next SAP or whatever will not be developed simply by drag and drop and doing some no-code, low-code. So we wanted to make sure that even when we keep that vision, don't install anything locally, you can still code ABL, business logic, and of course also UI logic in JavaScript, TypeScript, which turned out to be the easy part. Mm-hmm. The ABL part was and still is the challenging one.
Yep. Okay, so a little demo time.
Yes, now for the interesting part. Let's see if it works. Yeah, to this one first. Yep. So this is a sample application developed with Build.One. I'm not going into any details here. It's an application, complex sales application with customers, offer order maintenance, maintaining complex products, bill of materials, and things like that. And the interesting part is here the orange menu items. Maybe fun fact is that the whole Build.One platform was developed with Build.One. So there is actually no difference in a Build.One application screen or application and Build.One itself. And that's why it's possible here that we just mix, in this case, the application and the development platform. So the only difference here, if you work with it, and of course that's role-based and based on security settings. So if I am a developer, or if I have a developer role, and in this sample here, I have the developer role, I have the salesperson role, I have the admin role. So I am many, and that means I see all of this. A normal user would only see those menu items, and you can also set it in a way that you only see the development parts. And here in Build.One, everything, all the screens, everything is stored as metadata in a repository. So here I searched, filtered by some screens. This is a demo screen I recently created, so I quickly opened it just to get you an idea of how that looks. So this is a screen It's the designer from Build.One. So here I'm designing a screen, which will be a window with multiple panels, and we have a grid or browse, some form, and we have a tab here. If I click on that tab, on the right, I can, for example, say, come on, I want to have 2 panels here, so I choose a different layout. Sorry, I'm struggling a bit with the mouse. So now I have another panel here, and now I could, for example, go through all my list of objects, search for another form, or maybe search for a Google Maps control or something like that, and drag and drop it onto that new panel. And now I see Google Maps, and here you see in that designer you don't see it WYSIWYG, you see it, you only see the layout. So this is what we call the layout or screen designer. And you can work like that, just to give you an idea, so I'm not going into much detail. And you can open multiple windows at the same time. So what we really implemented is a kind of macOS or Windows OS inside the browser. Becomes more obvious when I do something like that. So now you see I've opened the Build.One designer 2 times, and I can switch between those windows. I have something like a Windows taskbar here. I can switch back to the main menu. And now if I go to this part, if the mouse lets me do it. So here we have integration with Jira and with Bitbucket. Also can also integrate with GitHub or GitLab. And here we, in this case, we see all the Scrum and Kanban boards from our Jira. That's actually our production Jira, so that's the real Build.One data. And you see that we just did the rebranding recently. Internally, our Scrum board is still named Axioma. And this is something from a POC that we recently did. So if I click on this one, here I would see all the sprints from this board. If I go to this sample sprint here, there's only a sample board, there's only 1 sprint. These are 3 test tickets or issues. If I click on this issue, here I see the actual code. So that's the branches, the Git branches, in this case from Bitbucket, which have implemented and which contain the code for this issue. And I could launch now a workspace, a Gitpod workspace for this branch. And that means when I click on that, we fire up a new workspace. And it will, after it has completely started, meaning it's basically it started the Docker container with all the development stuff inside, the progress, OpenEdge, the database, the PASOE, Build.One, and all that stuff. After that, we fetch the corresponding Git branch, and then you are ready to code. And from the browser, you can connect to that workspace. So basically, that's the same that we can do here. So this is the Gitpod UI. So here I can also say, okay, I want to open this workspace for this sports backend project and branch. I can just open it here. Or?
Yep.
So let's open that here. Did it work or no?
Yes.
Yeah. And maybe you can explain a bit better what's happening now.
So now we're getting into the Gitpod side where we've cheated a bit and pre-started this environment and then saved it off. But every time that you stop development, say you're in the middle of doing development in a workspace and you stop it, it actually gets saved off, and Gitpod actually takes a copy of all the data that you're working on, all the containers and everything that you've got in your stack, and saves that off as an intermediate image that's stored as part of the Gitpod environment, and actually takes a snapshot of all of your code and data and stores that in an S3-backed repository, so that you always have a snapshot. If you leave the Gitpod environment and leave it alone for I think it's more than 30 minutes, it'll actually automatically shut down and it'll save a snapshot that you can always pre-start again. And it'll keep any code changes that you've got that you haven't committed yet. So in that way, they do it to save resources, and you can adjust the time marks that you get on that. What it's doing now is it's actually pulling pulling the image of the development workspace. It's a pretty big image because the environment itself is a big Docker image that has a lot of tools inside it, and we've also got a full development stack in there it's actually Docker inside a Docker container that we're running inside a web browser. And as this starts up, it actually checks to see whether there's a README file in the project and then previews that. It then starts up. We've got some terminals that are running down here that are starting up. You can configure Gitpod to run specific tasks as part of your setup, and then start up your, for example, in this particular case here, what we've done specifically for this setup is we're running a Docker Compose stack inside the Docker workspace, so that we're starting up databases, PASOE, all the different components that I talked about before. And we then also at the same time get a preview, because we've exposed some ports of containers that are running. We automatically get a web preview that's actually logged into an instance of the application. So a full instance of the application with databases, PASOE, everything running in Docker containers inside this development workspace. So that when you, if you log in here, then you're logging into a running instance of the application that you can actually test with. So depending on what it is you're testing on the back end, or as part of your workspace here, you can actually, you can be modifying code and then see it in your preview. Depending on whether you're working on UI, you're working on back-end code, the approach will be slightly different. But the whole idea is that you've got a fully contained environment inside your web browser here.
What you see here really is Docker. It's a Docker container running the development environment, running Visual Studio Code with Build.One and all that stuff. And then inside the Docker container, and you correct me if I talk nonsense here, because he's the expert, the Docker expert. Inside the Docker container that we basically see here, there are other Docker containers, so Docker inside Docker, which have the PASOE, the database, Node.js, and all the other parts of that whole application. It's really the whole stack that makes up a Build.One application. And we also have a browser in the browser, as you see here. So with that environment, all from the browser, we could now start opening our famous sports.
Can you increase the font size a little bit, because the live print
we can probably do that if
we could close this one
here, and then maybe Control+ will. Yeah, so you can see we're in. Probably a little difficult for the people in the room to see, but you've got, because we have an OpenEdge, the existing OpenEdge plugin set up and configured. The databases that are running in containers here are set up, the Docker Compose stack is set up so the databases, the ports are exposed to the development environment. So the OpenEdge plugin is connected to the databases that are running in the Docker Compose stack. So in that way we can get, you can code, and you've got syntax checking against the databases that are actually running in your containers, all contained within this one environment.
And if you, this is really, or starting a complete new development workspace from scratch currently takes about 4 to 5 minutes. And that's really the equivalent to onboarding a new developer. And if you compare it to setting up your whole development machine, that's what I personally, when we looked at Docker, I liked it right from the start as a deployment mechanism, but for me it was not that urgent. And we implemented it, then I saw some very nice success when we installed OpenEdge Data Direct Hybrid Data Pipeline, which takes about 1.5 or 2 days to set it up. And with the Docker container, it took a bit more than an hour. And we implement, or we installed a BPM system that was also available as a Docker container, which really took only 10 minutes from when I sent a chat message to DevOps, asked him, could you, when you find some time, test that or make it available? And really 10 minutes later, I got a reply with the link in our environment where I could access it. So I started liking the whole Docker stuff, but it was not that urgent for me. But what I always wanted is really being more agile, being faster, being more flexible in the development part. Because you have developers, then they switch between tasks. You need to pull all your latest source code for that branch. You need to compile. You need to build and all kind of stuff. When they are finished with a task, set it to review. They switch their environment to another one. I want to look at it. I need to do a build, make it somewhere available. We have, of course, test environments. We have Jenkins, all the CI/CD stuff. But you never have enough environments. And if I want to say I need exactly this version that's currently deployed to the customer, or I need to have this specific branch or Git commit or whatever, it was never as flexible as I liked it. And with this here, really, you can fire up as many development workspaces within 5 minutes for any given environment. And that's really, I personally think that this is the way that software will be developed in the future. And I talked to the founder from Gitpod, and he said when he thinks when looking back in 2 years, we will say that this year was the year where the development workspaces as code started, and I also think that that's true. Basically, you can think about it like CI/CD for your builds. This is the same for your development, basically. And the limiting factor, unfortunately, at the moment is the ABL part. You see we have some color, syntax highlighting and stuff, but that part is not comparable to a developer studio yet. But developing in other languages, it works very well.
So maybe just very quickly, a bit of a review of what's in the environment here. So I've got several terminals started up here. I'm just going to close.
You can't really see the text still. You can see how is it?
Okay, we'll try and zoom in a little more.
But it's just some maybe, so we wouldn't have
but
to had invest, and we didn't need to invest the time to make the plugin work if you can't read it anyway.
You have the idea over here. We've got a terminal that's open over here, and the interesting thing is if we look at the Docker containers that are running over on the left-hand side here, I don't know if you can see that, but let's see if I can just pull this down. You can see we've got a number of different Docker containers running in here, and we can start up a terminal. This terminal session that I have over here is actually in what is it, tool? This is running inside the, where is it, tool hub? .sh. I have a terminal here that's actually running inside the main, in this case, a development OpenEdge container that has their development toolkit inside it. So if I need to, I can work with and I can compile and save my code as individual files, but if I need to do other things like recompile the whole code set right now, because we don't have an extension or plugin that does that automatically, because we've got it all built into the container, we can access tools that we have available already that are running in a container here, and for example go in and do a if I want to compile the sports backend code, it will then start in this case PCT compiles, that's compiling the code out, and I get fresh R code that's actually generated, that's available in my IDE here, so you can see I've got fresh R code over here on the left-hand side that I can work with. So in that way, we're getting the best of both worlds. We've got the IDE that we can work with, but we also have a comprehensive tool set that's available inside the container that we're working with. That's just part of the stack here.
It's also similar with when I showed you the Jira integration in the Build.One UI. There you can build beta branches, you could commit and push stuff, but you could also, of course, if you want to go to the command line here and do your git commit and whatever you prefer. That's the whole idea of Build.One platform, that no code, low code, code, whatever you prefer. And here you really, it's inside your browser, it's like a complete development machine with everything that you need or that you want. Yeah?
So when you say inside your browser, what browser are we talking about?
Doesn't matter, I think.
Well, in this case, it's Chrome.
What are our options?
I would expect that Safari would work as well. I haven't actually tried it.
But it works on my iPad, so.
Can you repeat the question for the stream?
Tom's asking what browser the environment works in, and I think it works on all major browsers because the VS Code server is. I must admit I haven't tested on a MacBook because I don't have one, but I would expect it to work on both Safari, Chrome, and Firefox.
So we are using currently a MacBook, so it's working there. I don't have one, but almost every other Build.One employee uses Mac, so it's working there. I tested it on my iPad Pro. It's working there with the browser, and Chrome and Firefox. That's the one we tested. And it will work on Edge because it's also just Chrome.
So in this case here, we're running on the hosted Gitpod service, which means that they handle all the hardware, all the the workspaces, the resource for spinning up containers and storing them and storing the data and so on. It is also possible to set up your own. So if you want to keep everything in a private stack, you can do that. The biggest challenge we've had with that is it uses a lot of disk space because the containers are pretty big. That the containers that we're creating, both for the workspaces themselves, but for the OpenEdge stack, are pretty big as well. So each workspace represents about somewhere between 5 and 10 gigabytes of data every time you spin up a new workspace.
And it's disk space and disk I/O. What we realized in our own cloud, in our private cloud, we realized that it requires quite some disk I/O because it copies 5 or 7 gigabyte as an image. Also, if you stop the container and it will, correct me if I'm wrong, it will compress everything and store it in an S3 storage. Mm-hmm. And if you spin up the container again, it will again start the Docker container, and then it will read all your changes. So you will have it exactly like the way you left it here, and it's reading back everything from S3 storage. So you need some good disk I/O. We tested it on an environment which is limited to, I think, what was it?
500
IOPS, and with multiple workspaces generating them all at the same time. We ran into issues.
So you need to be connected when you're running this too. You can't do this when you're unconnected.
You have to be connected. Yes. Yeah. That's obviously a caveat of a completely online-based, browser-based environment. But what you could actually do is the same setup. So exactly the same configuration. You could have, if you have on your MacBook, or if you have a Windows machine with Docker Desktop on, you could have the same environment running on your local Docker installation, so that you do the same checkout from your Git repo, start the same Docker Compose stack that we're using as the supporting OpenEdge stack that works with the development environment, and then work with that on your local machine. So because that was really our starting point, was we actually installed all of this on a Linux host, and then we've translated that into the web into the browser-based environment instead. And when you're working with for example, with Gitpod, one of the things you then get is if you're working with, for example, GitLab or GitHub or Bitbucket, then you get a Gitpod button here. So when you go and select a specific branch in your repo or a specific merge request, you can, if you press the Gitpod button here, it'll start up and spin up a new environment. Now here's detecting I've already got an environment running, which has this funny name here, White Leopard UG something. So I already have a workspace running on this particular branch and this particular repo. Do I just want to switch to that, or do I want to actually start up a new workspace? If I click on new workspace, we may not wait for this to finish, but then it's going to basically create a whole new environment with a fresh copy of the code that's available.
And in our case, the way we set up all our images is really they create a database from scratch, import data. So it's really like you would set up a completely new physical machine. So that's all stuff we need to improve. We need to have multiple images where we use one central database in a network and things like that. So there's a lot of stuff that we need to improve on. But the overall idea I really like. So it's exactly what we were looking for the last 2 years, being able to fire up as many development workspaces as you like within a few minutes. And yeah.
So if I just jump over to the dashboard I have here, I can see I've got some environments here, and one of the other things you can do is you can set up what are called prebuilds. So if you've got a build process that happens inside your workspace, for example, in this case here, one of the heavier processes is actually doing the initial pull of the images that we need to start up our OpenEdge stack. When we commit changes to a certain branch into Git of our project, Gitpod will, through webhooks into our Git repository, will trigger what's called a prebuild, and it will then run, depending on how we've configured the workspace or the project, it will then run some pre-build processes that will basically, for example, pull all the images we need so that when I go into, for example, the sports backend environment here, I can see here that there's a pre-build that's ready for this Gitpod branch. And that means that this branch here is going to start up quite a bit faster than if I take one of the other branches that doesn't have a pre-build on, because it's already pre-pulled the images for me. Now that could also be code compilations or other things that happen as part of creating an environment that's ready for you to get started with working with. One of the latest things that they've just added is they've just added support for, actually this one's actually just come up, so as we were talking, this new environment, this is a brand new environment that's actually pulled my containers. You'll see down here it says this task ran as a workspace pre-build, so it saved me a few minutes. It's pulled the containers, it's started the stack, it's got the environment up and running. They've also recently integrated with something called Tailscale, which is a private VPN clustering technology that you can set up on your PCs and your servers, but you can also set it up with your development workspaces. So if you need, for example, to have a development stack that needs to connect to, let's say, databases that are running on a server that you have somewhere where you've got a big database that doesn't make sense to be running in the browser, then you actually have private VPN network connectivity between your browser-based development environment and stuff that's in your back-end infrastructure. So you could be testing against certain databases and so on. So that makes it, begins to expand the use of the browser-based environments also.
What we have set up is that you can create a new environment. We want to use that for trial versions and stuff like that, where you say, give it a project name, sample or whatever, or sports and some other data, and then it fires up such an environment, and then it makes it available through routing or whatever, so that you can then, after 5 minutes later, you can, in your local browser, you can say sports.build.one, and you have your fully working development environment, your private environment with all that stuff in it.
So essentially, just to summarize, what we get in a workspace, in a development environment like this, is a workspace. It's running in a container. You're accessing it with a web browser. We've got our IDE that you can see with the files on the left-hand side. We've got a Docker Compose stack. This is just what we've set up for this environment. If you're working on an Angular web UI or something like that, then you probably wouldn't have all the Docker Compose stuff, but you could have other things that are running, because you can configure your Gitpod workspaces. There's a .gitpod.yaml file that you configure with startup tasks, with things that happen in a certain order, so that you basically pre-configure your environment. So in this case, because we need an OpenEdge environment running to support our development environment, that's what we're starting up in Docker Compose here. We have terminals that we can access and run command line stuff inside the workspace, but also inside each of the containers. You've got the preview browse, which runs inside the workspace, but it's actually also, that's one of the things we didn't show, but if you're running your preview here, you can actually pull it out and run it as a separate browse window here. And you can share a running workspace as well. So if I want to share my workspace and have Bronco look at something, I can go in and select to share my workspace and send him a link that he can then click on, and he'll actually open up in the same running workspace. So we'll actually be looking at the same code, and you can actually be two people coding at the same time inside the same workspace. So it opens up quite a few interesting possibilities.
Although you need to get your head around it. Docker in Docker and browser in the browser and all. And basically it's a lot of Docker containers inside that one Docker container. There's a network between those and all that stuff. But nice thing is really basically you define your development workspaces. Yeah, and then you just change the definition by adding stuff to that file, and then you can have complete with just a few lines of code, no, not really code, but yeah, YAML stuff, as the experts say. With a few changes, you have a container that does not fire up its own database Docker container, but uses a multi-tenant database in your network or something like that, just by a different definition. And so I think that's how you could describe it. It's really development workspaces by definitions, and not by installing something and scripting and stuff like that.
Obviously, it requires a little prep to set up and get it all configured and so on, but then it becomes very useful.
Plan was that we have it ready by beginning of the year, and here we will have it ready almost exactly beginning of the year, but I was 1 year later. Yeah. It took some time, but I think it was worth the effort. Yeah.
Yep.
What is the typical size of a workspace when you run it? From a memory consumption point of view?
That would depend on the size of your Docker Compose stack. So in terms of disk space, in terms of the images and volumes and everything you create, these environments here are somewhere between 5 and 10 gigabytes in size. In terms of memory, it would depend on how many databases we're starting up and the PAS-OE instances and so on. So, and you almost know more about that than I do. So.
No, what I was thinking, if you run 50 developers on all these workspaces, how much developers can you accommodate on one machine?
Well, that's if you're setting up a self-hosted environment, so you're setting up your own infrastructure to manage this, then you're obviously going to take that into consideration. Gitpod is built to be running on Kubernetes, so either on something like K3s or running on Google Cloud or AWS, and you need to make sure you've got enough compute power and memory and disk space for the number of developers and the number of workspaces, because you end up actually using quite a lot of disk space. If you then look at the hosted environment that Gitpod provide, and you let them do it, then it's their problem, and it's actually not that expensive to use their setup. Yeah, and they've got some pretty big infrastructure because they have over 400,000 users that are actively using them. A lot of them are free. It's open source, so you can install it and configure it yourself. But and you can use up to, I think, 50 hours of development time for free on Gitpod, and otherwise there are paid plans that you can go in. And I think the first 10 developers are free. If you want more than that on a plan, then you have to start paying for it.
So you basically ended with all those expensive MacBooks
being Chromebooks. Yeah, could be.
That's not, I mean, for performance-wise, it doesn't make a difference if you have that big MacBook Pro or if you have just an iPad or, well, an iPad Pro nowadays is also quite powerful. But yeah, you just need a browser, that's all.
The compilation of the progress source is integrated in Visual Studio Code?
So the question is whether the compilation of code is integrated into Visual Studio Code. With the existing plugin, you can get basic compilation of individual files as you're working with them. So if you wanted to have your own compilation, the process I showed before was actually build tools that Build.One have that we've containerized. So we were executing those from within a container, but because the workspace, I actually forgot to say that, but the workspace that we started up actually was built with an OpenEdge container that we've added the Gitport tools to. So the ID, when you log into an editor, to a terminal and start that up, you have a full OpenEdge environment in there. So if you've got scripts that are running Ant and PCT and those kinds of things, then you can do all the compilations that you need directly from there. So that's part of what makes the initial workspace very big as well, because we've got a full OpenEdge environment inside that also. Yeah. We just need a little more fancy tooling in terms of Visual Studio Code, and I know someone who's actually working on that at the moment. I think you do as well. So, yep.
So that's the real limit, or actually the only issue we face with this at the moment is there are 3 plugins at the moment for Visual Studio Code, 3 OpenEdge plugins. We tested them, and they are more or less side projects from several people in the OpenEdge community. The one we are using, I think the guy is not actively developing it anymore. I think he's no longer in the OpenEdge.
He's not working with OpenEdge anymore.
So that's the important part. And either Progress comes up with a language server protocol, or Chill, hopefully. Thomas saw it, and that looked very promising.
Interesting for those of you who are interested in Visual Studio Code with OpenEdge. Go and see Gilles' presentation on the language server, because he's doing some interesting things there, and that gives some interesting opportunities. So just to wrap up, yes?
One more question?
One question from online.
Okay.
Carl Verbiest asks, what is the best way to get extra information on Build.One? Is there a trial available?
Well, the best way is to go to our website, and there you can request demos, POCs, trials. We are currently, actually after all the stuff you saw here, the main reason we did this is to being able to create trial versions quickly. We have just tested it last week for the first time with all non-development and non-technical people at Build.One. Everybody was able to successfully start a development workspace within 4 to 5 minutes, so that seems to work. And beginning next year, I think we'll make that publicly available, so that on our website, if you click on a button, you get a full-featured development workspace.
Right, cool.
Yep. Okay.
There was another question there.
Yeah, licensing. Like, do you have a deal with Progress on how all this is licensed when you have 5 or 10 or 20 or 30 developers?
That's a good question. Well, if you have the PASOE, you start the instance of the PASOE.
You need to bring you need to have whatever licensing is needed for the Progress, for the OpenEdge stack that you need in there. You've got to be licensed with Progress for the appropriate.
With your own license.
Yes, yeah. Because the whole reason that the whole way that we design and we build OpenEdge images is that they don't have licenses built in. So you've got to attach your own one. So so that you are not distributing pre-built images with some licenses in there.
So bring your own license.
Yeah, BYOL. Yeah. So next steps for a project like this is obviously we've got the development environment, but we've got some work to do also in looking at actually the whole deployment side of things and moving into Kubernetes and to the more professional deployment environments now that we've got the basic building blocks in place that we need, just like it is for any other OpenEdge based projects that we work on with containers.
I think we already covered the questions part, or are there more questions
Any other
online?
questions?
That's pretty much it.
Yeah.
Okay, right.
Thanks a
Any
lot.
other questions from the floor? No?
No.
Okay, well, thank you very much for attending and
Thank you.
enjoy the rest of the summer.